accuracy, precision, and percent error. Every measurement we make in chemistry is a comparison of the physical quantity being measured with a fixed standard measurement, such as the second, or the centimeter, or the millimeter. There are two words which describe these comparisons: accuracy and precision. Accuracy refers to how close a measurement is to the true or correct value for the quantity. If I was throwing darts, hitting the bullseye if I was aiming for it would be accurate. Or in chemistry, if I am recording the volume of a liquid, maybe it's 18.7 milliliters, but I record it as 19 milliliters. How close I am to that true value is how accurate I was at reading it. Precision refers to how close a set of measurements are to each other. If I repeat reading 3 times and get the same amount each time, then I'm very precise. I could be doing the same thing wrong each time, and so my measurements may not be accurate, but they're precise. So if I'm throwing darts and I hit 3 over here on the 16, then that is precise, but it's not accurate if I'm aiming for the bullseye. So for each of the following dart examples, the bullseye for the dartboard represents the true or correct value. Under each picture, describe if it is accurate or precise or both. So for this first one, if we're aiming for the center, all of them hit the center, so I'm accurate, and they're all very close to each other, so it is precise as well. So good precision and good accuracy. In this case, since I'm aiming for the bullseye and I don't hit the bullseye, I'm not very accurate, but I am precise. And in this third example, I didn't hit the bullseye, nor are my shots very close to each other, so poor accuracy and poor precision. If we wanted to measure out 50 milliliters of water for a lab, which piece of equipment would give the most precise results? We have a 250 milliliter beaker, a 50 milliliter Erlenmeyer, and a 100 milliliter graduated cylinder. If you said the 50 milliliter Erlenmeyer, you're wrong, because we do not measure volume with Erlenmeyer flasks. If you look at it, it goes 40 and 50. So there's not very many gradations or tick marks, leading to a low level of accuracy and precision. You said beaker, you're also wrong. Remember that we do not measure volume with beakers. Again, this one has 25 milliliter gradation, so it's a little bit better than the Erlenmeyer, but not much. You said graduated cylinder, you are correct. Graduated cylinders have lots of gradations or tick marks, leading to better accuracy and better precision. Go ahead and pause the video and try this one on your own. Restart when you have an answer. So the actual mass was 48.44. None of the masses that the student got are really that close to 48. So I would say no, the student is not precise because there's too large of a difference between the masses that they did and the actual mass. Is the student precise? I would say yes, because they are pretty close to each other. They have a small range. Decide if the following are accurate or precise. Restart when you have an answer. If a person makes 99 out of 100 shots, I would say they're pretty accurate. They're also pretty precise. That's a pretty good precision. If 99 out of 100 shots hit the front of the rim and bounce off, again, assuming our aim is to make a basket, they're not very accurate. They only made one of them. but they are very precise. If they just change one little thing, then they could probably make 99 out of 100. And finally, 33 out of 100 shots are made. The rest either hit the rim or just rebound off the backboard. 1/3 isn't very accurate, and they're not all in the same spot. They're not very precise either. So in this case, they're neither accurate nor precise. That leads us to percent error, because sometimes you think that a student is accurate or precise or accurate. So how close is close enough? That's where we use percent error. Depending on the lab, sometimes a 2% error is good. Other times 10% error is good, depending on what you were doing in the lab and how many steps we had. So percent error is experimental value, so what we got in the lab, minus the actual value over actual value. Remember that these little lines mean absolute value, so it should always be a positive number when you get done with that step, times 100. So experimental is our lab value. Actual is the true value. I'm going to pause the video and try this sample question on your own. So this value is my actual, and this one is my experimental. So we should have the true or actual value should always be on there twice, top and bottom. We get 1.50%. When you're calculating percent, it's going to keep 2 decimal places. 1.5% is pretty good percent error. And that concludes this video.